I just pulled task number 6. I checked out my tag for task number 6. Again, I'm doing this through git checkout task 6. And the first thing I want us to look at is how for task number 6, the goal for task number 6 is to implement, we're going to implement receive and sync. So we want to sync the wallet and we want to be able to receive funds. Those are the two things we want to do here. So it's not the biggest of tasks, but there is a bit of background and again some Android stuff, Android specific stuff. So the first thing I want you to look at is the 2 new dependencies we've added to our Gradle file. We've added this QR code generator and this ZXing core library. So this is a library that is a bit old at this point, but it's really the library for QR codes, for generating QR codes on Android. And that's the one we use. So when we share Bitcoin addresses, you've probably seen this with Callie. By the way, if anybody knows how to pronounce his name, I think it's Callie, but I know he's German. So let me know in the chat if I'm pronouncing it right, if he told you how to pronounce it. And hopefully we can cut this out of the recording because I'm a big fan of his. His book is right there. Callie, if you're watching this, I love your work, man. I read your whole book, but I don't actually know how to pronounce your name. So hopefully it's Callie. And the way we're doing this here is when we share Bitcoin addresses, we can share them in the format of strings, right? This sort of like TB1, whatever, or we can share them in QR code format. So those are 2 completely valid ways to encode the same information, right? Again, Bitcoin addresses are what they really are is really numbers, right? So that's what we want to share, and those 2 ways are perfectly valid. So I'm pulling in this QR code implementation because that's a very common way to share addresses on Android, on mobile, is through these QR codes. And the fragment we're going to go to is the receive fragment. So if you get onto your receive fragment, the first thing, actually before that, we're going to go into our resources layouts. And if you go into the fragment receive layout, you'll find, if we split this between the code, we have again a constraint layout with a text view, image view, another text view, right, for the receive address, and then the button to generate, the button to generate a new address, and a button to return back to the wallet. That's pretty much all it is. It's a title, the QR code image, the string for the address, and then a button to generate new ones, and a button to go back. That's it. My receive fragment, however, is a bit more complicated, and what it does is pull on that QR code library. And I don't want to dig into that too much. You can look at their documentation. They have a clean, pretty good README that gives you good examples on how to pull a QR code. And we're basically creating that QR code, and we're giving it a background color and a front color. I don't know how to call it, but like the other side of a QR code, right? There's like the black dot, the black squares, and the white background. So we're giving it a background and a front ground, if you will, and then we just generate the QR code based on a string. So we have this new address that we generate here on line 48. With this new address, notice again, once we've implemented our wallet class with the BDK connection there, it's super easy to use. I'm just calling the wallet class, and I want to get the get new address method on it, and it just returns a string, and we're good to go. So now I have this new generated address that's in my value. Again, values, val for Kotlin, the val keyword. is the same as a variable, but it's a variable that can't be changed, so it's non-mutable. And so now once I have that, I log it on line 49, and then we create the QR code image for it. And then if it's valid, it'll be able to, we'll just simply go to that image. We'll simply go to that image and set the image on the view, on the binding, the QR code view. And that's it. And then once that's done, we also take the text for the receive address view, which is a text view, and we just add the text to it. So once we have that, it'll just like generate the address on the screen. Any questions on this? I'm going to try running it. Okay, so Sobi wallet, see the wallet is initialized at launch. We're saying, you know, it's opened successfully. The descriptors are here. Neat. I've got my wallet. Things are working. I should be able to navigate to my recovery phrase. Notice we don't have a recovery phrase right now. It's not displaying it, right? We haven't implemented that. And if I go to receive, I get a perfectly working fragment. And if I ask to generate a new address, here we go. And if you look at the logcat, this particular line, line 49, is what's printing my new deposit address here. Neat. And it should be the same, you know, ending in 5J8C, 5J8C. There you go. And I should be able to scan that and send funds to it. And if I click on generate a new address, it'll just like create more of those. Boom, boom, boom. And go back to my wallet. That was easy. Like that was like genuinely easy, wasn't it? Like that's neat. And I'm adding the QR code stuff, so I don't even have to have the QR code. If you want to do it really, really basic, you could just have the string, and then that whole thing would be like 3 lines. So that's neat. And we're doing this through the generate new address button. Notice that again, it's just the idea is that we go into our bindings, the binding which grab all the views that have an ID on this layout. And in this case, we had an ID for that button. It's called the generate new address button, binding dot that, and then we set an on-click listener to it. And so that will just run the Lambda, right? What's after this is called a Lambda, and it basically will just run whatever you give it once the set on-click listener method is called. And what we run here is the display new address method, and it's here. Easy as pie. I'm going to check the chat. Okay, no questions so far. That was the easier part of that task. There's 2 parts. That's the easy one. The other one is to say we want to sync, right? And the sync is super simple in the sense that what we're doing is I'm going into my wallet class and I'm calling the sync function. And it doesn't even return anything. It returns unit, so there's nothing there. You don't even have to deal with the return value or with a return value, and nothing. It just prints to the screen that the wallet is successfully synced. It just prints, sorry, not to the screen, but to the logcat. It'll print that the wallet is successfully synced. The complex part of this comes with updating our UI. This here, right? The 000, we want to update this so that it reflects the balance. And this is where a bit of Android magic comes in. And what we're going to use here is something called a view model. And you're going to have to go and Google that once we're done if you want to understand more how it works. But the view model are a way to implement the observer pattern. And if you're not familiar with the observer pattern, I recommend my book back there. The observer pattern is a design pattern where we say some class will be holding data, will be sort of like in charge of whatever piece of data we want to have. Nice. The whole PDF. Sweet. That's actually really good. I didn't even have that myself. So that's even better because it's like searchable, right? Control F, and then you can get in there and search for anything. So thanks for that link. And what the design pattern says is, I'm holder of data. I sort of like handle data, and you can subscribe to me. And whenever that data changes, I'll just send you a ping. I'll just let you know, hey, this has changed, and you can just update with the new value, right? And so it's similar to subscribing maybe to a newspaper subscription, right? So the newspaper, you just call and you say, I want to subscribe to this newspaper or this newsletter or whatever. And whenever it comes out, somebody brings it to you. So the only thing you need to do is register for it, right? Is to subscribe to it. And that idea of like subscribing to an object that handles all that data and lets you know when that data changes is called the observer pattern. So you're an observer of that data. All right. Look it up. It's very interesting. And so what we want our fragments to be observers of the data for the view model. And the view model is basically the Android way of achieving this. And what we're doing in our case is creating a wallet view model class. You can have a view model for a lot of different things. So you in a single app, you might have multiple view models. So that's a very common thing to see. Although in our case, we're going to with one view model, and that the whole app is going to work with one view model. So take a look at my view model. It's the last file in my wallet package. And don't I make it easy for you? This is a 19-line file. How awesome. Except that to really understand what's happening, that might take you a full week of research and like reading documentation. So that's where the beauty of Android comes in. Such complex procedures and behaviors can be encapsulated in very little code. So once you understand what's happening in the background, you're very expressive, and you have like these superpowers, right? You can achieve so much in so little code. So that's one of the beauty of this whole approach. So what we're doing here, my line number 9, right? I'm extending this Android view model class, and I'm calling it the wallet view model. And what we're going to do with it is create these variables that are going to be of type, of type mutable live data. And so this mutable live data is this this type of data that is sort of always there, always live, and can be mutated, and we let know our observers, we let them know that this data has been updated. So this mutable live data class is a generic, and in our case, it's of type, the generic is of type long. Long is like the long version of an integer, right? So we want to be able to capture any value of Satoshis the wallet could hold. So an int is not long enough for it. We need to use long, and it starts with the value 0. And so this balance is just there. And if you look at my wallet fragment, you will find that this wallet fragment has registered for the view model, right? I create the view model on line 30, and I'm registering for it. I'm observing it on line 39. This is where the magic comes in. I'm saying view model, which I've imported, the balance variable on it, I want to observe it. And then, I give it a few things. And whenever that value will change, we'll receive sort of a not a notification, but sort of like a it'll ping our class and say, hey, this value's changed, and it will fire the lambda that we have here. And sorry, this here, yeah, this lambda will get fired up. And in my case, what I'm doing is whenever that value changes, I grab that value and then we put it in a format that is easy to read for the human eye. And this is for the Bitcoin format, basically. So you is that are you following along here? What we're doing is, again, to sort of like wrap it up, we create this balanced variable that is of type mutable live data. And whenever it changes, it'll let all the observers know. So it only has to say, hey, I'm observable. And then everybody else wants to subscribe to that data can just do so using something like my line 39. I want to observe it. That's what I do. So from any UI perspective, again, the cool part of this is that the UI doesn't really know how that data gets updated. It doesn't know that it's coming from a Bitcoin wallet. It has no sense of all of that sort of complexity, right? All it knows is that it's observing this little number, and it's just a long. So easiest thing, it just observes it. And whenever that thing changes, it fires up a little function. And this is what we're doing here. I'm firing up the function to display it. And now you might be thinking, well, okay, so but how do we, that complexity, right, of like updating it, where does it reside? And it resides in the wallet view model. And in this case, it's the function update balance. And it's super easy. What I do when I want to update my balance is I call the wallet.sync method, which we talked about earlier. It's here, right? It doesn't return anything, and that's all it is. So I sync it, and then I go and I get it. I get that new balance, and that's another method. It's called the get balance method, which returns a long, if I'm not mistaken. We're gonna go to it. So with Android Studio, if you do command and then you click on it, it'll go right to it. So function get balance returns a long, and it's really just a wrapper for the get balance method on the lib, on our native lib, right? So I'm creating this value called new balance, and then I'm using a method called post value. This is really the heart of the view model, where I'm saying post this new value, this new balance. I want to post it, and this method is the method that basically sends the ping to all the observers to say, hey, we've changed. So it's updating the variable here, and it's also sending the message to all the observers saying, hey, I have a new value now. And that's how the new observers, not only do I have a new value, but also here is the value, right? So the observers who are observing that data simply grab it and then do whatever they want with it. So that's what's happening here. And that's how we update the balance. How does that sound? Do you guys want to try a transaction? How does that? I have a chat. Somebody in the chat here. Is the view model same as the Redux state management? A good question. I'm not as familiar with the Redux state management, but yes, I think that the gist of it is very similar. If you think of it's actually, no, sorry, Redux. If you're familiar with Redux, it really is state changes, right, that are immutable. So you're creating state, and you change that state over time, and so that allows you to sort of go back in time, to go back to any of the previous states. This is not what's happening with the mutable live data here. So in that sense, it's a bit different. But otherwise, yes, I think that the mental model behind the Redux system is similar, where you say, we're going to hold all of that data here. You guys don't worry about it. And then whenever we change, I'm going to let you know. And we go back and forth like that. And everybody else just has to sort of like listen in and say, has anybody changed? Like, has anything changed? And can decide to register for different things. I don't know if Redux, you register for all of the pieces, or if you just get all the state sort of like all at once. I did some web development, but not I didn't get into Redux too much, so yeah. So I want to copy this address, and we're going to try sending to it. So I have this Bitcoin faucet. Sometimes it, okay, 11. Transaction was sent. Nice little amount. We can grab this TXID, go into our mempool.space. I want to show you another tool because we talked about tools earlier. And another good block explorer is the blockstream.info block explorer. There should be. Actually, I'm surprised. I thought there was a testnet part of this Bitcoin testnet. There you go. Okay, they changed the UI actually probably like yesterday or the day before because I haven't seen this, but Blockstream, if you're not familiar with them, is one of the big companies in the game for Bitcoin, and they're the ones that we connect to with the Electrum server, and they also offer Block Explorer. And so here we are. I'm seeing that this conversation, this transaction has one confirmation rather, and it was sent, it's mined, all of that. Look at that. It arrived at our address. So now if I go back to my wallet here, hopefully a sync should show us that amount. Boom. Oh, I'm happy it did because this is recorded forever. So would have looked bad if it didn't work. And if I look at my logcat, well, it was successfully synced, the new balances, whatever, and then a deposit address, whatever. We have all of that stuff. All right, so I think that this is a good end for this particular task. Let me know if you have any questions on this task before we move on. But I think what I'm gonna recommend you do is we're gonna do a breakout room, because I think people wanted more breaks and more time to code themselves. So try to run this yourself, send yourself some testnet coins if you can, and copy from the logcat. Make sure you copy your wallet descriptor. So put it in a, just a text file on the side if you're going to send coins to that. So that way you can, if you delete the app, or if anything, you don't necessarily want to lose the testnet coins. Or I recommend that when you go into the faucet, put a much smaller amount, put 001 or something. So it's a really small amount. But as long as you copy that descriptor, you'll be able to reload the wallet. You could do it in the app, or you could do it on the CLI, so you'll be able to send those coins. But right now we don't even have a send. The send button is not implemented, so you won't be able to send them back. So yeah, does that make sense? So we're gonna go into breakout rooms, and I'm gonna give you one of two tasks. You can do them as a group, or you can do them individually, but just chat about them, or you can even ask me in the chat any questions you have. But what I think you should try to implement is one of two things. Either you go into the about fragment, and I think you should fix this up. Okay, so one of two things. One, try to add a little paragraph here. So that will require a text view and a little explanation maybe as to what the summer of Bitcoin is, and maybe another text box there that adds the donation address back to our testnet faucet. So this address here at the bottom, the MKHS9, this is a really important address, and you don't necessarily want to have to copy paste it all the time, go back to the website. this is the faucet we're using for this workshop, and I want to make sure we return all of our testnet coins to them. Like, I mean, you have to understand faucets. Testnet coins are actually hard to find. It's not, at some point you had to buy them even. Like I heard stories of people buying testnet coins because they're not easy to find. So the people who run these faucets are like, this is just like doing the Lord's work. So we want to make sure we give them the coins back. And so you want the users of the wallet to be able to find that donation address back easily. So make sure you let people know that it's a testnet address, obviously, for donating back your testnet coins. But I think if we put the address in there, that'd be great. So that's one thing you could try to add. Or the other thing you should try to implement is a third option, which would be called setting. Just a little fragment with nothing in it right now, but it'd be something we can add to in the future. And to give you an idea of where to go for that, it would be in the wallet fragment here. If you look at the wallet fragment, sorry, the wallet activity, my bad. And the wallet activity is connecting this what's called an overflow menu. Look at how I have like two choices here, the menu recovery phrase, menu about. There would be a third one here, which would be sort of like an RID menu settings or whatever. And that gets defined in my menu here, the overflow menu. If you look at the code, has two items. We would want to add a third one called settings. And then it'll appear in your wallet activity here, and you'll be able to call it. And then you'll need a fragment. So anyway, I think that this is maybe more than a 15-minute breakout room, but if you want to try something a bit harder, just do that. All right.